Welcome all. Today we will discuss about the second module of partial differential equations and integral equations. Uh, we will discuss about the first chapter of the second module, that is chapter number 5, the method of separation of variables. This chapter mainly discuss about the method of separation of variables and solving the heat equation with this method. Finding the solution for the heat equation in the homogeneous and non-homogeneous case with the homogeneous boundary conditions using the method of separation of variables. Okay, so let's start the session. Um, we know that the method of the second order linear differential equations is of the form f of x y u ux uy uxx uyy and uxy is equal to 0, or we can write it as f of u ux uy uxx uyy comma uxy equal to 0. Now the method of separation of variables is a method for solving the second order linear PDE, partial differential equations. And in this method, the solution is expected as a product form. That means the solution u equal to u of xy is considered as or expected as a function of x into a function of y. That means x of x into y of y, or simply xy. So the solution is a product one, product of the two functions, or we can separate the solution as a function of x alone and as a function of y alone. So that's why this solution here, it is known as product solution or separated solution. So once we assume that the solution is in this form, we can clearly have ux, the first derivative of u with respect to x is will be uh, x dash of x into y of y. Since it is u is explicitly written as a function of x and y alone, x of x and y of y. So y of y will be constant when we are differentiating with respect to x. So this is in the ordinary different derivative form. Okay, and uy will be x of x into y dash of y, like this, and then uxx will be x double dash y, and uyy will be xy double dash or y double prime, and uxy or uyx, if the function is continuous, it is in the form x dash y dash or y dash x dash. That's the same since it is a product. Okay, so like this. So once we replace all the function u and its derivatives, partial derivatives with respect to, and the second order, first order and partial derivatives in the equation, in the given equation, we can transform the equation star given by star into a function of epsilon, and we can separate the functions of x and y, or we can have it as, or we can transform it as uh, like this, that is g of x prime x double prime is equal to another function. We can separate the two functions, that is in y dash and y double dash, like this. So the equation star can be written like this. And when we equate, since these two are equal, and when this is uh, And since the left is a function of x alone and this right side is a function of y alone, the function of y, and both will be equal, or this will hold only if this is equal to a constant, let it be k. Then taking the two functions separately and equating the two, that is g of x, x prime, x double prime equal to k, and h of y, y prime, y double prime equal to k, we will get two second order differential equations in the variables x and y. Then solving these two differential equations, ordinary differential equations, we will get, solving this, we will get x as a function of x, and the second one solving it, we will get it as a function of y. That means first one is a function, is a different, first one is a ordinary differential equation with a dependent variable capital X and independent variable small x. Similarly, the second equation is a second order ordinary differential equation in the in dependent variable y and independent variable small y. So the solving these two equations, we will get x of x and y of y, so that u is equal to xy, or x of x into y of y is the solution of the given PDE, partial differential equation, which is in the linear form. Okay. So we first apply the method of separation of variables for solving the heat equation. So next we consider the solution, solving the method of solving heat equation with the homogeneous boundary conditions by the method of separation of variables.